All right, in section 8, which is our last section of module 1, we're going to talk about inverse functions. Now, an inverse function is a function that essentially is going to undo a function. So it's a new function that undoes a function. And we typically denote it f inverse of x. So it's a new function f inverse of x that undoes a function. So if we want to think of an example of this, if I take a function f of x, let's say f of 2, so I plug in 2 to some function, and let's say I get the number 5. So the x value is 2, and then my corresponding y value or functional value is 5. Well, the inverse should be able to get me back to where I started. So if I take the f inverse of 5, then I should get back to where I started, of 2. So I take the y value from the function, and I get the x value from the original function. So you start with a number, you get some other number. Taking that number into the inverse will get you back to where you started. This would be analogous to if I gave everyone 2 points, bonus points today. Then to undo that, I would subtract 2 bonus points and get you back to where you started. So we're going to try to find these inverse functions, talk a little bit about inverse functions, and see how they work. There are a couple easy ways to see if things are inverse functions. There are 2 properties that typically will show if inverse or functions are inverses. One, we say 2 functions, f of x and g of x, are inverses if f composed with g of x is the same as g composed of f of x, and those both have to equal x. So if they take their compositions, then they both should equal x. The second way they could do it is both graphs should be symmetric to the line y equals x, which is just our regular old symmetric line. So those are 2 real easy ways to see if functions are inverses. If their compositions are both equal to x, and if their graphs are symmetric to y equals x. Now, another quick thing sometimes we use is what's called the horizontal line test. Now, the horizontal line test, remember, is kind of like the vertical line test. It's only going horizontal. And we say a function only has an inverse function if it passes the horizontal line test. So we had this vertical line test to see if it was a function, and the horizontal line test will be to see if it has an inverse function. So that's kind of some theory on inverses. What we'll really focus on in this class is we're going to actually try to find some inverses. So if I give you a function, how do we find its inverse? So the way we're going to find an inverse is we are going to use the fact that the x from the original function and the y of the original function becomes the y and the x of the inverse function, just in reverse order. So the way we're going to find an inverse is we are always just going to switch the x and y values and resolve for y. So let's do a really easy example real fast. So let's say that I have a function, like we talked about earlier, that I'm going to give everyone's grade a bonus. I'm going to add 2 points. So I have f of x equal to x plus 2. Well, remember, f of x works like the y value, so this is really y equals x plus 2. So if I want to find the inverse, which should be subtracting 2 points, I'll switch the x and y. So x equal y plus 2. And then I'll get y by itself, which would just be subtracting 2 from both sides. So y equals x minus 2. So that is now the inverse function of our original. Now, a lot of the algebra can get a little tricky on some of these, but in essence, that's what we'll do. Switch x and y, and then resolve for that y value. So here are two examples, and we want to determine if the inverse functions are inverse functions. So I want to know if this thing had an inverse function, is it a function? So in this case, this one is not, because if I take a horizontal line test, it does not pass the horizontal line test. So this does not have an inverse function. Now our second example is just a line, and obviously lines always have inverse functions. I can pass that lots of times. So this one does have an inverse function. So you don't want to go and start trying to find an inverse function if one doesn't exist. Now sometimes there are inverse relationships, but in general we're just going to focus on finding inverse functions. So here's a couple examples of how we'll find inverses and just a little bit more about an inverse. So this says if the point 2, negative 3 is on the graph of f of x, what point has to be on the inverse? So what this is essentially telling us is this is saying if we take f of 2, because that's the x value, that equals negative 3. Well, then if I want to undo that, f inverse, we would take f inverse, remember, of what we ended the function with. So f inverse of negative 3 would equal 2. So the point on the f inverse that we have to know that is on there is going to be negative 3 and 2. And again, you can see the idea that both of these points, the inverse and the function, just reverse each other. So you're switching the x and y, just how we find the inverses, just how we do most things with inverses. So the last thing we really want to talk about is how do we find inverses. So I want to find the inverses of these couple of functions below. So this first one is simply just a line. F of x equals 2x plus 9. So if I want to find the inverse, remember I'm going to switch x and y and solve for y. So remember, this is the function y equal 2x plus 9, because f of x is the same as y. So I'm going to switch x and y. So x equals 2y plus 9. And so from there, I'm going to try to solve for y. So I'll subtract 9 from both sides. So I get x minus 9 equals 2y. And then I'll divide both sides by 2. So y equals x minus 9 over 2. So f inverse is x minus 9 over 2. Now, a quick way to check this is not a very thorough check, but we can do a real quick check. I'm going to take my original function f of x, and I'm just going to pick a point. So let's take the point 1. So if I put 1 into f of x, 2 times 1 plus 9 is 11. So 111 is on f of x. So if that's true, then 1 should be on f inverse. So we can check, if we plug in 11 in the inverse, do we get 1? Well, we get 11 minus 9 over 2, which is 2 over 2, which is 1. So at least for that 1 point, it seems that our inverse is correct. Let's look at a little trickier one. This is a rational function, a reciprocal function, so we know it has a domain problem. It can't be negative 2. So we're going to try to do the same thing where we switch x and y and solve for y. Now, a little more complicated because of the fraction. So we'll start with y equals 3 over x plus 2. Switching that f of x or whatever the function notation into y. And then we're going to switch x and y. So that's going to give us x equals 3 over y plus 2. Now this is a little trickier because our variable is in the denominator and not in the numerator where we like it. So the general way we approach these is we're just going to multiply by whatever that denominator is. So in this case it's y plus 2 to both sides. And that will cancel that factor out. So I'm going to get y plus 2 times x equals 3. As I know there's lots of ways to go from here. I think the easiest way is simply just divide by x. So I get y plus 2 equals 3 over x. And then I can subtract 2 from both sides. So y equals 3 over x minus 2. So that is a fine way to write the inverse, 3 over x minus 2. You could also put these together by getting common denominators. So if you wanted to simplify it a little more, remember if you have two fractions you want to get together, you have to give them common denominators. So I'll add an x to top and bottom here. And so I could write this as 3 minus 2x over the common denominator of x. So these two things are the same function, just written in a little different ways. But if you're looking at a multiple choice question or something like that, it might be helpful to know that it could be written a little different. All right, last question deals with our squaring function. F of x equals x squared minus 5. Now, this one is very interesting because if I think of the graph of this function, x squared minus 5, I get this graph. But you can see this fails the horizontal line test. It hits twice. So this is not going to have an inverse function per se. Now, we can still find an inverse relationship, but we know that relationship is not going to be true for all values of x. And when we see the inverse, I'll show you why that's true. So this is y equals x squared minus 5. So if I switch it, I'm going to get x equals y squared minus 5. So I'll add 5 to both sides because I'm trying to get that y by itself. So I get y squared. So now to get rid of the square, I'm going to take a square root. And this is where we get tricky. So remember, when you take a square root, you need to add a plus and minus. So because we have the plus and minus, this is going to give us basically two parts of the graph that aren't going to be a function. So if I were to graph these two, one is going to look like this and one is going to look something like this. So that's not a function. Generally what we do is we just restrict it. We basically ignore the negative sign and we just say the inverse of x is going to be square root of x plus 5. But we know the domain of this is only negative 5 to infinity, while the domain of the original was every number. So there is quite a difference there. It's a little, have to kind of restrict it a little bit. So that's kind of how we deal with the square root problems when they do arise. So inverse functions are very important because obviously if you have a function, it's very important to be able to undo that function. So if you have questions, please let me know on this last section of Unit 1.